Hello students, we were discussing the interference handling mechanism in CDMA networks. In continuation of that, today our discussion will be on interference handling by soft handover. Last class we have discussed the interference handling by power control mechanism. We will see actually how the second mechanism also be very helpful and how does it help us to handle the interference in the practical networks. So, in a CDMA network we understand that already this conclusion we got from the last discussion on the power control mechanism, that we will deploy the network, the CDMA network in a single cluster mode. We call it a cluster 1, or we sometimes call it is a cluster 1 cross 1, means single cluster and single frequency. And if we are not using a cluster 1 cross 1, then we will have the clusters where actually the frequencies, the cluster 1 cross 1, where actually the same frequencies are allotted in the multiple clusters. So, cluster 1 cross 1 is an example here and cluster 1 is here. So, if this is the situation, so any in both the cases, as the frequency that is getting used for the transmission for all the mobile users are exactly the same, then there is a possibility that you will get a high intra-cell as well as inter-cell interference. And even a single mobile station in such situation, when I am in a neighboring zone where my all the neighbors are using the same center frequency, especially the mobile users who are located in the boundary of the cell or the cluster, they will actually play the major role in creating the and controlling the total interference of the network. Basically, the users who of any cluster who are sitting in the boundary zone, they will be creating interference to the immediately next neighbors clusters and neighbor cells. And this may be something like this, can be explained something like this. Suppose this is a mobile base station, this is a cell number 0. So, it has a base station equal to 0, and this is a mobile station, let me name it as mobile station 0. Let us have another base station 1, which is a base station of the neighboring cell, cell 1. So, I have a cell 0 with a base station 0, I have a cell 1 with base station 1, and mobile station 0 is within the cell 0, and mobile station 0 is now located at the boundary of the cell 0. This is the situation. And also think of a situation that mobile station 0 was initially allocated to base station 0, and he is transmitting using the power control mechanism governed by the base station 0. So, he is measuring his own distance from the base station 0, and then he is controlling the power for transmission according to the calculated distance and all the power control mechanisms that we have already discussed in the last module. And it may happen, now see and think a situation that currently though it is served by this guy of this base station 0, and the highest received level of the power, if it is as it was enrolled to the base station 0, because whatever the power it was receiving from both the base stations instantaneously, it was found that actually received power was more from the base station 0. So, it was allocated to the base station 0. But now think a situation when this thing has happened. So, what we draw some figure like this. So, we had two cells, one is having the base station 0, another is having base station 1. Mobile station is close to the boundary of the cell 0, he was transmitting actually via the power control mechanism, and he is enrolled to base station 0. Why he was enrolled? We discussed that because he measured the received power level from both the base stations, and he found that the received power level is more from base station 0. So, he was enrolled to the base station 0. Now, think of a situation that because of the because of the change of the fading condition change of the environment, suddenly the channel between the base station 1 to this mobile station 0, it got better compared to the base station mobile station 0 to base station 0. So, I repeat, the channel is now very good between base station 1 to mobile station 0 compared to the channel between mobile station 0 to base station 0. So, the why by means of channel is good, we mean the fading is very less, fading is very less. So, the power with which this mobile station is now transmitting, the power that it will that is received by base station 0 and the power received by base station 1, if I compare under the situation when the channel here is good compared to the channel between MS 0 to BS 0, you will suddenly see that the power that is getting received from MS 0 to base station 1 is more compared to the power that is getting received by the MS 0 to BS 0. It may happen because of the sudden change in the fading condition of the environment, and because of that now what will happen, this power, this mobile station 0 power will be working as an heavy interference on the overall the signals that the base station 1 is receiving from his own cell mobile users. So, this situation is a completely unwanted one, and maybe because of very few milliseconds this phenomena has happened, and after that the channel condition has got reversed, and anyway again the mobile station 0 is found to be good with the to be associated with the base station 0. And again actually the interference power transmission is not received power from the MS 0 is not such that the interference is high, but because of that, but that may be actually the most of the cases, but in between for those milliseconds time when the because of the good condition of the channel, the power received from the MS 0 to base station was became suddenly so high that it totally damaged the communication within that cell 1. So, this is possible, and hence this is the reason why actually we are discussing this soft handover is required. The certain situation like this demands that you should not control the power control, you should not give the command for the power control of the mobile users who are actually in the boundary of the both cells by any one of the base stations. Its power control command should go from jointly from base station 1 as well as base station 0. So, eventually what we are demanding is it is something like that the base station 1 and base station 0 should cooperate with each other to some extent, and they will actually jointly at any particular time jointly they should actually instruct the mobile station to control the power, so that the interference profile of say both the cells are maintained. It should not be actually going beyond some certain threshold of the individual cells. It may happen, why we are talking about only 2 base stations, it may happen actually that the other neighboring cells are having also the same kind of the phenomena. True it is, because but then we may actually come to the conclusion that out of all the neighboring cells who are having this kind of the effect from mobile station 0, those two, at least 2 of them who are having the significant effect from the power transmitted by mobile station 0 should take part actually in the decision of in the decision process of this of mobile station's power control. So, how do we implement this soft handover? We understand now that we are having 2 different kind of the communication direction. One is the uplink direction, which is from the mobile station to the base station going on. Another is the downlink communication, where the base station to the mobile station communication will be going on. So, in the uplink direction soft handover is implemented basically by 2 types. So, the two mechanisms are there. It is something like this. So, this is suppose my base station 1 and this is my base station 0. So, if I am having, if it is a downlink direction and I am a mobile station whose power control is required to be controlled by both of them, I will receive signal from both the base stations, and here I have a rake receiver architecture that already is discussed in the CDMA fundamentals, that we are having the rake receiver architecture, where inside the rake receiver architecture we will go by the maximum ratio combining techniques. At the output of the rake receiver we will process both the signals from both the base stations, and then we will go by the maximum ratio combining to get the to take the final decision and go ahead with the power control mechanism. Another technique is that each involved these base stations, they perform the channel decoding for the received signals and adds a frame to what they will do that in the downlink again. Each of these base station will perform the channel decoding of the received signal in the uplink and adds a frame reliable, which will tell that when they decoded this typical frame or typical packet. So, what exactly was the reliability indicator? So, they will add actually one field in the frame format. So, which will tell that what is the reliability associated with this decoded frame. So, the frame, both the frames will be transferred from this base station to the radio network controller. Both the base stations will decode the frame and they will send it there, and the radio network controller will pick up whichever is having the higher reliable indicator. So, he will pick up the packet which is having a higher reliable indicator. So, like that it may go on. Remember actually this rec receiver concept, this one is mostly used, this is called the soft handover in the UMTS, and it has highest performance in terms of the dB gain that is performed. The highest, if I understand that the highest data rate is also to be considered to transfer all the received signals to the combining element and all. Then actually therefore, if the highest data rate is also needs to be addressed at the same time, then it will be applied only for the base stations and that are installed at the same site, not the base stations of different all the sites. So, to choose the base stations whose signals will be combined in the mobile station as well as whose signals will be really relevant related to one mobile station inside the RNC, that there is a call actually to choose the base stations to who will be considered for the typical mobile station of our consideration. Thus, there is a second method, I mean where actually there is a second method where the base station performs the decoding option and all. So, the uplink software handover, where actually in the UMTS sometimes we apply in that situation, that uplink software handover and then connecting it to the RNC and taking a decision there and doing the selection combining in some extent of the data frames, that is done. So, that is all about the uplink soft handovers and all, and power control mechanisms during your uplink, power control mechanisms during your uplink is much more critical, because we understand that the mobile users cannot be synchronized in the uplink direction. So, this is much more critical, that we have also discussed in the last module when we were discussing the power control mechanism also. So, uplink, that is why we are so critical about the consideration of the uplink power control or the interference handling in the uplink direction already and always. And sometimes actually the rec receiver that I told that you can do actually in the downlink direction, the rec receiver stuff can also be applied in the base stations, because you may actually signal processed by the rec receivers of all involved base stations can be combined actually, and so there is a central controller who will receive the signals from the multiple base stations and then in the RNC. Not the decoded one, the raw one, and then he will do he will implement the rec receiver there, and then he will implement all the stuff and maximum ratio combining. By maximum ratio combining, he will take a decision. Second method says that they will decode and they will put a indicator, channel indicator, and then they will send, and whichever is having the best indication they will choose. So, the first one, where actually from mobile station to the where the rec receiver concept is utilized, is the most famous one in the UMTS that we have discussed. But soft handover in the downlink direction, this soft handover is performed by transmitting the same data to the mobile station from the multiple base stations. So, now think of a situation like this. Now, we are having the multiple base stations 0, 1, 3, 4, 5, and here is my mobile station. So, the mobile station will receive the signal from multiple one, and the way actually the things were combined earlier in the RNC to form the rec receiver, here inside the mobile receiver we may have the rec receiver architecture, and here inside that mobile receiver can control can have a rec receiver architecture, and he can actually take a decision by the maximum ratio combining. Remember that if we are using the cluster 1, then all the base stations will be using the same frequency. So, in that situation, though the transmitted signals are not properly synchronized, they are roughly synchronized approximately within a microseconds. From mobile standpoint of view, he can view actually all the signals coming as if actually it is a multipass signal coming to it. That is why actually equivalently by using the rec receiver architecture, he can get the read of the he can actually get the final decision about the power control, and they can because hence he is combining everything by the rec receiver. But only modification in the correlation architecture that we have to do here is, if we are not using the same frequency from all the base stations are not using the same frequency and they are utilizing the different frequencies. So, in that case the same rec finger architecture can be rec receiver architecture can be utilized, but for the different fingers for correlation you have to choose the different kind of the codes of those base station cells, and then you add the then you apply the maximum ratio combining. But remember actually that all the rec fingers that we deploy in the mobile station, that should be limited, and so fingers in the mobile station is also limited, and that also limits the number of the input signals that you can combine and you can utilize for the processing. So, as this soft handover is now in place, you will see that there are two different kind of the gains are involved in this soft handover process. The number one is the micro diversity gain, and this gain comes from the fact of the short term fading. Another is the macro diversity gain, this comes along the long term fading. So, we understood that these two fading we will actually we are associated with the channel, and this is over the short term duration, the change of the channel that we are seeing that we observe, and this is over the long time duration if the changes that the channel take place. And but whatever be the changes in the channel, this soft handover has the capacity to encompass both of them and provide the gain over both kind of the fading. And this macro diversity gain, this one is really profitable to switch the connection. So, as if you wish to get this gain, so it should actually very fast. Finally, actually if you see the output of this receiver or the after the maximum ratio combining, whatever the decision output you will see at the output of the output of the mobile station, finally your target will be to switch from one base station to the next base station to get the highest SNR, received SNR. But if I see the macro diversity gain, it will be obviously profitable if you switch from the one to the next base station as fast as possible to get the highest gain. But remember how fast this handover should happen, there is a very big question. So, based on what actually you will go ahead with this handover. Suppose you are getting controlled by two base stations 0 to 1, and suddenly you realize you have to switch between base station 1 and 2, say instead 0 should be discarded. So, will you switch on very fast actually once you realize, or when, and what is the threshold, where is the decision point that will dictate you to switch from the one base station to the next. So, that is a very big question, and we generally set up a strategy of this handover. So, we also need to understand, though we understand that very fast switching is possible, which is demanded, but we should understand that if you switch between the cells every on and off now, so then there will be very hard actually going, it continuously will be going forward and backward kind of the handover. Instead of doing that, what we do is actually we keep on actually weighting the average level of the received SINRs over a certain period of the time sitting inside the for a typical mobile station. and we introduce the concept of the hysteresis margin of some decibels. I mean, this is a typical decibels. If we see that it is going below this level, the power of a typical cell is going below say certain level, then only actually we will discard accepting the signal from that cell, and we will actually incorporate a new cell base station to take part in the power control mechanism, and hence that new cell that is getting added. So, power is handover is there from the base station 0 to that new base station say 2. For example, if you give based on some practical data measured, for example, this 4 dB may be a reasonable, people found that 4 dB is a reasonable threshold level of the old cell. If the average level of the old cell go below the 4 dB, the signal to noise power, received signal to noise power from the old cell go below the 4 dB value, then we hard handover process is initiated with respect to some mobile station. And remember that for a hard handover, that may have several phases, that may be phases of some seconds actually, where the mobile station is not served by the base station with the best local mean of the signal level, and where the performance may be lower than your soft handover process and all. But we have to bear with all that only because the instantaneous to and fro movement of any process, any soft handover process actually leads to lot of the control signal transmission over the network, as well as actually it is a hazardous also for the mobile station to quickly switch from the actually from one cell to the next. So, there are lot of the control information as well as actually lot of data exchange is required whenever some handover happens. That is why we have introduced in the last slide the some hysteresis level. So, we have heard about two handovers now, the hard and the soft handover, and with respect to the macro diversity, it depends on this gain that you achieve from that and the performance between both of them. It depends largely on the averaging length over how much time actually you are averaging from the current cell, and the hysteresis margin, the dB level gap that you have kept to decide the handover. And both of this part, they largely depend upon the three things. One is the mobile velocity, the standard deviation and the cross correlation length of the long term fading channel, and the tolerable rate of the handovers, how fast handover you can tolerate in the network as well as in the mobile station. So, is it allowed or not? So, based on that your handover will be going on. So, approximately it is very difficult to quantify how much macro diversity gain you can achieve for a typical kind of the long term fading, but still we got some practical data, and that practical data says that approximately the order of the magnitude of the gain that you see is in the order of the 1.2 dB, the coverage can be improved by around 1.2 dB. If we go ahead by this micro diversity gain, exactly we can get around 1.2 dB improvement in the coverage probability, where the SIR at 95%, at the SIR of 95%. These are the some results recorded in practice. And now, if I come to the total gist and a summary of this soft handover, what we have gained. We understood that soft handover is earnestly required in the CDMA network with the cluster 1 architecture, mainly to control the inter-cell interference for the mobile stations who are residing in the cell border. And we understood that it can be implemented in the downlink as well as in the uplink, and it is quite simple way that the way the cluster 1 and the CDMA in the downlink direction it will be applied. In the downlink it will be applied by the rec receiver architecture in the mobile stations. In the uplink we can apply it either by the rec receiver architecture in the RNC or by decoding the received packet inside the base station, and then further adding a channel indicator or reliability indicator value in each of the packets from the different mobile stations, and the RNC, which is the radio network controller, who sees actually all the packets received from the different base stations and see what is the reliability indicator, and chooses that packet who is having the highest reliability indicator in that. And if I compare the soft handover with the hard handover, gain of several decibels, though it is based on many parameters, the gain that you achieve by the soft handover, it is much higher compared to the hard handover case. The gain is achieved, though we are thinking that the gain will be achieved, but remember this soft handover is such that you are incorporating lot of the network resources. For example, multiple base stations you are involving to decide whether the handover is required or not, whereas in the hard handover only one mobile station, he is taking care of the incoming signals and then taking the decision whether to go or not. So, he is doing the handover only by seeing or measuring the average level of the SIR of the old cell, and whenever he is going down below certain level of certain dB level, then only he is taking the part, he is taking the decision to handover. So, that is the hard handover, but soft handover is not like that. It is not observing only the receipt power from the current cell, also the receipt power from the multiple cells are taking part into the process. So, though it is giving a higher gain, but it involves actually large resources in the network. The gain is achieved, that is why with the additional cost for the transmission lines, additional cost for the transmission time also, and the resources from the network. Soft handover is the process of this soft handover is not only restricted to CDMA networks, you can apply it on any other kind of the networks, and even by very simple example is inside the equalizer also. And this switching between the cells with different frequency carriers if you are dealing with, and then actually then there will be a hierarchical cell structure. For example, so this is the there is a micro macro femto cell concept, where the center frequencies that are used in the different cells, they may be actually different. In such kind of the situation, the hard handover has to be used, requiring some additional effort. Hard handover for this CDMA techniques, that needs to be requiring some additional effort as compared to the hard handover in the TDMA networks, because of the hierarchy of that different kind of the central frequency that we are using. So, in gist, that what we learned here is that soft handover is a very essential part and preferable part for the CDMA networks, for the network deployment, and especially for the users who are standing and who are there in the cell boundary. And compared to the hard handover, we prefer the soft handover because its gain achieved is much higher, but at the same time should remember that it involves large amount of the resources in the network, numbers of the base stations involved. So, numbers of the transmission processes involved, and the other processing involved inside the base station as well as in the mobile station.